Okay. Yeah. Any guess? So this is the reason generally we use something called flag. So initially flag value is set to 0, that if element is found, then instead of writing this, I will say that now flag value should change to 1. Once everything is done, I will check if flag equals 0, or let's say 1. Then I'll say print element present. Okay. Else print element not present. Okay, so this time just saying okay, element present, let's make it 4000. Now it will say not present. Okay, now in Python we actually don't need this. Okay, just to remove this flagging logic, we have something called optional else block for your for loop. Okay, so how it works. If your loop completes successfully, then it will go to the else block. Okay. In case of while executing loop, if it encounters a break statement, it will not go to the else block. Okay. So if you are evaluating this, if key is equals to 4000, right? It will check if condition, this will be false, go to the next iteration. For all the iteration, it will be false, right? So compare this, no, go to next, no, go to next, no, go to next, go to next, go to next, this is the end, right? In this case, your break statement will not get executed, right? But now let's take a condition of 400. Check this, okay, go to next. Check this, no, go to next. This, okay. It will check that this is equals, print key is present and break. If your break gets executed, it will not go to the else block. Okay, so that is the reason I can use this to see. Okay, now in this case, let's say key is present. Let's make it 4000, element not present.
So this else is outside of that if.
Exactly. So this is not the else block for your if.
Okay.
This is a else block for your for loop. Okay, and this is optional one. Okay, so understood how it will work? That if a break get executed, it will not go to the else. It will directly start executing from here. Okay, so if I execute this now, element not present and statement after from. If I just specify something which exists, it will say key is present. It will not go to the else block. It will directly start execution from the next statement. Okay. So the main intention is to remove flagging logic. Okay.
But like mostly like the else we like on the computer this if you are looking for we don't use else block.
Exactly. So there is no programming language other than Python at the moment supports else block for your.
And take like how will it be effective? It means like how its usability is.
So it's exactly similar. Whenever you use flag in C and Java, the same code you can write using else block in your Python. And actually, this flagging logic is used extensively in C and in Java.
Yeah.
So all those programs can be
If I'm not
converted.
using an else block,
That is also fine. That is also
then
fine.
later it doesn't make sense, right?
Which one?
If I'm not using the else for the for loop,
Uh-huh.
then break will it make any sense?
It makes sense. It makes sense. In that case, you are reducing the number of iterations. Okay. So now, till now we have seen that I'm directly dealing with values. So in each iteration, I'll get a value to the this in this variable, right? If you see the syntax is in your C and in Java, you say something like for I equals to 0, I less than 10, or something I plus plus, right? So this is initialization, this is my condition, and this is increment, right? Whenever you are specifying this, you are generally meaning it by indexes, right? If you're working with arrays, you generally specify this, consider this I as an index, and you work on the basis of that. But in Python, you are working on the basis of values, okay? Let's say in the same example, I want to print if key is present, at what index this particular key is present. So if I directly say for value in L, it will only give me the value. Now I want two things, one index and the value. Okay. So we have something called enumerate. Okay. Now this enumerate function will give me two values to iterate now. The first value will always be your index and second will be the normal value. Okay. So what I'll do, just forget this. Value in well, enumerate of all. I said this will give me two things, index and value. Okay. So this will give me at 0th position 100 is present, at first position 200 is present, at second position 300, third position 400. Your index will start from 0. Okay. So if I directly just say for in only L, I will get only values. But if in case if I need an index also, I can make use of this enumerate function. Okay. So how we can use this in this case, that I want to print if element is present, then at what index that particular element is. Okay. So here I'm saying print key is present. Here I'll just put a comma and I'll just say index. Okay, so now it will say key is present at third. So was the key 400, it's 0, 1, 2, and 3. Okay, so now in each iteration I will get 0, 100, 1, 200, 2, 300, 3, 400. That's why I have two values. So one is index, second is value. So I'll just compare the value, and if yes, then I'll print the index also. Okay. Any queries in enumerate?
Index will be a keyword here, not a variable.
It is a variable. So all the problems when we need index, we will go with enumerate. So all your searching sorting algorithms we generally play around with the index, right? So if you have a list, you want to swap the values, you want to change the indexes. Okay. So there is one more approach that we will also discuss. Okay, before now here, I'm changing it to A comma B. Now what is this A? A is index and B is value. So here instead of value, I'm saying equals to B, and here I'm saying this. Say this. Okay, I'll get the similar input. So these are two user-defined variables. Okay, we will come back to this enumerate function when we will start discussing about tuples. Okay,
So basically, enumerate gives it like assigns two values to two variables.
Exactly.
The one is first is the index and the next is the value.
Alright, as we started with this, I'll just explain this thing. It's not necessary that you have to write it to variables. So I can say something like this also for x in L, enumerate of L.
Then it can be used, enumerate must be used only with list, tuples and set.
Only iterable, so all the iterable data types, yeah. So it's the same case, right? So I cannot write a number here anyway, okay? So ideally, actually, so this enumerate will return me a tuple. You can see this is I'm enclosing in a round brackets. So that's why this is a tuple. Okay, so these are two values. That is, first is index, second is value. Okay, so tuple is a separate data type. Okay, so which is similar to your list, but it's immutable. So we'll come to that again. So one way is I can accept it into two separate variables, index comma value, or I can accept it into a single variable as a tuple. So now if I want all the values only, I can say x of 0. This will give me only index. If I say x of 1. Okay. So we'll come back to this part again when we discuss tuples. Okay. But got the idea? Enumerate will give you two things, index and the value. Okay. So we have discussed some example and we tried addition of a list, right? Now let's say I want addition of first 20 numbers. Okay. Or next time I say I want addition of 1 to 1000 numbers. Okay. I will not go and I'll create a list is equals to 1, 2, 3, 4 till 1000, right? So for that we have something called range. So this is also iterable data type. So we have different variations. So first is if I say range of 5, this will give me numbers from 1, 2, 3, 4. Okay. Keep in mind your end is not inclusive. I'm sorry, we'll start with 0. Okay, so your end is not inclusive. So whenever I specify only one element, it will be considered as an end which is not inclusive. So it will defaultly start from 0, 1, 2, and 4. Next, I can say something like this 10, 15. So now I'm specifying the start and I'm specifying the end. So this will be 10, 11, 12, 13 till 49. Okay, your end is not inclusive. If you want the increment of 5, so this will be like 10, 15, 20, 25, 30, 35, and so on till. Okay, so the last number cannot be 50 because 50 is not inclusive. Okay, so in the same program, all I need to do just replace it. So I'm saying sum is equals to 0 again. I'll say for value in range, let's say I want sum of 1 to 20. What should I write? 1 to 20? 21. So this is the case. So in each iteration, I'll get one element. So just for seeing the value, printing the values in, and I'll say sum is equals to sum plus value. So in each iteration, now I'll get numbers starting from 1 till 20, and at last I'm printing the sum, that is 202. Okay, so just specifying instead of L, I'm specifying it a range. So this is actually a separate class called range. Okay. So if I say let's take any variable range of 1 to 50, and if I say print type of L, and even if I try to print this L, okay, so this is a separate class called range, and this will give me an object actually, and which is a iterable object.
This is not treated as a data.
No, this is not a data type. No, no. Actually, in Python, we do not have concept of data type. Okay, so that is the reason you will always see that something as a class and a range. Okay, so whenever we see int, string, and everything in C and Java, we have something called primitive data types, right? But in Python, everything is a object. So somewhere in the backend, they have written a file with class as a range, or class as a string, or a class as a list. Okay, so we will discuss more on yeah.
Can we initialize from a floating value like 11.7 or
Which one? In a range?
In range?
No, no, no. So range is only for your integers. Okay. I think we can initialize the number, but I cannot. We cannot increment it by that. Let me give it a try. So let's see if I say 50. Mm, no. So it strictly takes integer only. Okay. So we have discussed enumerate. Now there is a one more approach if you only want to work with indexes. Okay. So if I have a list 10, 20, 30, 40, and 50 and 60. Okay. Now I am not mainly interested in values. Okay. I'm working on a sorting, let's say, and I'm only interested in indexes. Okay. So if I want a length, I have a built-in function called len. Okay. So it will calculate the length and it will give me. Okay. Got it. So have a look here. I'm saying for, I'm not saying value this time, x in range len of L. If I check the indexes 0, 1, 2, 3, 4, and 5. Okay. Alright. So we have seen range function. Whatever I will specify to the range function, it will, if I'm specifying a single number, it will start from 0 and go to that particular number, right? Now this is my range function. Go inside, what is this? len of L. If I evaluate this, len of L will be 6, right? So in short, in the back end, it will be range of 6. So that means it will start a number, generate a numbers from 0, 1, 2, 3, 4, and 5. And that is exactly your indexes. Okay. So actually, if I use this, then L of X. So if I say L of 0, this will give me 10. L of 1, 20. L of 2, 30. Right? Okay. So this is another approach if you only want to work with indexes. Okay, I will calculate range, and range will be actual length of the list or length of the iterable. Clear to everyone, or should I repeat? Yeah. Let's move on to the next. Okay, so this is for loop. Now we don't have much surprises in while loop. Okay, so while is exactly similar to your C or a Java while loop. So let's start with syntaxes again. So I'll write something called while. I need to specify condition here. So whenever I say condition, this should evaluate to either true or false. If it's true, then it will go inside the loop and it will execute the statements. Once the moment this condition becomes false, it will come out of the loop and it will start executing the statements. Okay. We also have optional else block, which works the same way, that if break statement gets executed, it will not go to the else, but if your loop completes successfully, then it will go to the else block. So same, if your break statement gets executed, it will not go to the else block. If your loop completes successfully without break, it will go to the else block. Okay, right. Now, whenever I specify while, I need to make sure I provide initialization, condition, and the increment. Okay, so which is exactly same in your C, in your Java. Yes. So let's try the same problem. I need to do sum of first 20 numbers using while loop this time. What should I write? So I'm taking one variable called count, initializing it from count. I need something to store my sum. I'll say while I'm putting a condition as count is less than or equal to 20, then sum is equals to sum plus count, most important statement, count plus equal to what's 23 sum. Okay. So I need to specify the initialization outside loop. I will be specifying condition here and I will specify increment. Initially count will be 1. It will check if 1 is less than 20, yes, then go inside, calculate the value of sum. Then increment the count, go up, check count less than 20, yes, continue, calculate the sum. So it will continue like that. Now let's take, you incremented the count, now your count value is 21. So it will check 21 less than equal to 20, condition is false. So it will not go inside the loop, it will continue from the next statement here. Okay. So the most important part is this increment. If I forget this, it will go into infinite loop. Okay. So clear. Right. Let's combine these two things now. Anyone remembers bubble sort?
There's a middle number and then
I'm not asking binary search.
you have to divide into lower. Oh,
I'm not asking binary search.
Bubble sort. You have to take one number and then you take it.
Alright. So I have something like this. Is it? Right. Let me put something like this. Right. So I'm going to add this 86 here. So how it works? I'll start from this number. Compare this with next number. Okay. If this number is greater than this, I will swap it. So I'll get 40, 50, 30, 20, and so on. Right. Now I will check this 50 with 30. This is not in correct position, so I'll say 30 here, 50 here. Okay. Now check 50 with 20. So again I need to swap it, something like this, 50 and 20. What we have after? So we have 10, 70, 25 and 45, right? Compare this, I need to swap. So this will be 10, 50. Now I will compare 50 with 70. This is in correct position. Next time I will compare 70 with 25. 25 and 70. And lastly I will compare 70 with 45. Okay. So in short, in first iteration, you will get one element at correct position. Okay. In the next iteration, if you keep on swapping, so this will be 30, 40, 20, 10, 50, 25, 45, and 70, right? Okay. So you will swap this. So your 40 will be somewhere here. So 40 and 20. So compare this. Then swap this one also. So 40. Now 40, 50. This is in correct order. Now compare 50 with 25. Not in correct order. So 25 and 50. 55, 45. Oops. 45, 50. In second, after second iteration, you will get two elements at correct position. In third iteration, you will get three elements at correct position. In the next iteration, you will get 4, 5 elements, 6 elements, next iteration 7, and at last 8. Okay. So in short, you will always need the total number of iteration, which is equal to length of your list. Right. So the only thing you have to do is compare the current element with next element. Okay. So in short, here I'm completely working with indexes only. I don't want value. So I want to element current element with next element, right? All right. Can you help me with this? Let's go step by step. So I'm saying for, okay, let's take it as x in. I want index, so I am going with range approach. Okay. Early enough. All right. Now in each iteration, I'll get first index. So now I want to compare the element which is present at this index with element present at this index, right? So what I'll say, if L of x is greater than L of x plus 1. If this is the case, that means the first element is greater, then I need to swap two things, right? How to swap two variables in Python? I will just need to write L of x plus 1, comma, L of x. Okay. If this is not, then I need to continue. Okay. So this is not full. So first thing, this will give an error. But let's sort this thing out. Right. So this is giving something list index out of range. Why? Because you are comparing this with this, this with this, this with this, this with this. At the end, you will compare 25, 45. Next, you will compare 45 with next element. Exactly. So I need to make sure that instead of this length of L, I'll say L minus 4. If I execute this, now you can see that it has moved one element at end, right? So in short, this is working, but this worked for only one iteration. All I need to do is repeat the same thing till length of this list. Okay. So that I'm just saying count is equals to 1 initially. Let's start with 0. I'll say while count is less than ln of L. And this should be inside. Oh my god. Anyone? What's the issue? No, I intentionally made this, but the issue was this. I was not implementing the count. So that's why it was going into infinite loop. Where's the parenthesis missing now? At the top. Okay, is it sorted? So we have seen that this loop will give me the element. So the one element will be at correct position. So if I repeat the same procedure, I will get second element at correct position. If I repeat the same procedure, I'll get third element at correct position. In short, I need to repeat the same procedure how many times? Till the length of this L. Okay, so that's why I'm adding this entire loop inside my while loop. Okay. Clear? So syntaxes of for loop and while loop is clear. Okay. Anyone knows what is perfect number? So let's take example this. Number is equals to 6. Okay. Find out the divisors which are less than number.
The sum of the divisors.
Exactly. So if I do sum of divisors, and now if sum is exactly equal to the number, then I can say this particular number is a perfect number. Alright. So write a program which will check if a number is a perfect number or not. Okay. So what's the logic? So I need to generate the numbers which will start from 1 till this 6, right? So which function will give me these numbers? Alright, so I'll do something called range. Okay. Uh, how to check if a number is a divisor or not? So in each iteration, I'll get a number. I need to check if I'm able to divide it completely by 1 or not. Logic? Okay. So same thing I'll check with 2. If this is completely divisible, then only I need to make sure that I count the addition.
But the iteration should be limited to only the half the value.
Ideally, yes, that is optimization. Right, so I'm saying like num is equals to 6. Let's say for value in range of, can I write only 6?
7.
Six floor division. Like
6?
floor.
Alright, okay. Alright, so let's make it something like this. Okay, yeah, will it work?
Yeah.
That should be the integer value.
But whenever I say only range, it will defaultly start from
1.
0. And if I try to divide a number, exactly. So this is the common error you will make, that if you try to divide a number by 0, Python will throw you 0 division error. Okay. So here I'll say 1 to this. If we imagine the condition of this, and that number will be okay. So this will not work. If I say 6 floor to 3. Now when I say whatever number I specify here is not inclusive, so this will actually iterate over only 1 and 2. Getting right? So here if I say num floor 2, answer will be 3, right? Now whenever I say range, your end is not inclusive. So in short, this will give me only numbers 1 and 2. It will not check if 3 is a divisor of 6 or not. Okay. So you have to write something like this plus. Okay. Alright, now this is perfect. So I'll check if number is getting completely divided by this value. If this is the thing, I'm just using this sum variable again. Then only I will do the sum is equals to sum plus value. Otherwise, I'll just ignore this. And the last step is I need to check if the sum is equal to this number or not. If this is equal, then I'll say this print. This is a perfect number. Else, I need to say not. Alright. Execute this. My bad, what I missed. Okay. So for 6, this is showing, okay, this is perfect number. Let's try for 7. Not a perfect number. Next perfect number is 28. Perfect number 29. Not a perfect. 5. Not perfect. Okay. This is the logic. So this is all about loops. Which one? Yes, that is also fine, but this is a optimized solution, you can see. Now if you check any number, let's take example of 28, right? Now if you go on finding the divisors, you will get 1, 2, 3, 8, 10, not 3, 4, 6, no, right? 7 you will get, 14 you will get. Now you will not get any divisors after 14. Because if you take any number that is 15, 15 to the is 30, right? So logically, you can restrict it to half of the number. It's just now for a range, I am saying half plus 1. Because otherwise it will not include this 14. Okay, so that go till 15 so that it will check last number as 14. Okay. You can try for prime number as a homework. Okay. So check if a number is prime number or not. Try to generate the Fibonacci series. What is Fibonacci series?
Sum of previous two numbers.
Exactly. Okay, so 3, 5, 8, 13, right? Try to find out the factorial of a number. Okay, keep in mind I can specify negative increment for the range. Okay. So we'll stop here for today. From next time we will start with strings. Okay. Guys, I will need your email IDs. So please help me with that.